Hi, welcome to another in our series of basic economics. This one is the second half of our story of equilibrium. So equilibrium 2. For this one we're going to be looking at going from preferences and production technology to the market. And how we go from looking at indifference curves and isoquants in order to and go into that demand and supply and the traditional things that you're expecting to see. Um, so when we look at a model of a market, we really want to think about what is a market. We started out talking about Adam Smith and looking at Adam Smith's view of a market, and we're sort of all, especially in the West, accustomed to thinking about markets. But really, what is a market, and how does a market work to allocate scarce resources? So when we're thinking about how to model that and think about it, we're going to start with the consumer and producer concepts that we've already introduced. Um, and then from there, we're going to define some of the assumptions that are used that underlie these models. And we've talked a little bit about those. From that, you want to derive your demand and supply curves, your marginal benefit and marginal cost curves. You're going to solve for equilibrium. And we'll kind of talk about or examine why other allocations are not optimal. So we want to start with the utility side of the story, the consumer side of the story. And so remember, utility is the satisfaction or happiness, and satisfaction is the best description of what this is. And remember that the utility is an ordinal measure. It's not something that you can measure. People have different levels of how they conceptualize the problem. So it's what we would call an ordinal ranking, not a cardinal ranking. We can't compare your utility to my utility. We have diminishing marginal returns. So the more we consume of any particular item, the less satisfaction we get per unit. So mathematically and graphically, we can put together something like this. So let's start with the budget constraint. The budget constraint is a linear equation. So we've got M, which is income. So basically what we're saying is that we're going to spend all of our income on two goods because we've simplified the world down to just two simple categories of goods. Typically we look at something like good A and good B, good X and good Y, guns and butter, two different types of, like two sort of goods that would capture everything that we need. So housing and food, for example. And you want to trade off how much housing versus how much food or whatever, and you're doing these things to get satisfaction, and you're trying to have, you have scarce resources, which is reflected in your income, and you want to maximize your satisfaction subject to how much income you earn. So you're going to spend all of your income on your two goods, in this case good X and good Y. And so how much you can consume of good X, so basically all of your income is the price of good X times how much X you consume, plus the price of good Y times how much you consume of good Y. This could be extended out to multiple goods. You can make it as complex as you wanted, but that doesn't help us in this case. So one of the things that we can do in order to be able to graph this is we can rearrange this budget line right here, and we can rearrange it to look like this down here. So one of the things that we can do is that we're going to want to get this y that's over here on the other side. So to do that, go through some basic algebra, rearrange it, and you end up with negative px over py is the slope of the budget constraint, and that'll be at the point x for some level of consumption. And then you have income divided by the price of y as your vertical intercept. And so that's this right here. So this is going to be b. So you've basically got y is equal to mx plus b, which is your linear form of an equation. So this is your slope, and that's the x value, and then this is your vertical intercept. So that's right here. And so if we start with utility A, this is where we start out, and we're right here. And this is where we are at equilibrium in the first place. So we have this level of consumption, y star naught, with this level of consumption, x star naught. And this is where our utility curve A, and our budget constraint in the initial place are equal. So that's that's where we could start. So then we want to examine what happens if income changes. So a change in income is reflected by some kind of shift of the curve. So you can have different things that happen in order to increase income. You can have an absolute increase in income, and that would allow you to increase all levels of consumption. So you would increase both consumption of X and Y because you have more income available. But in order to kind of do the analysis we're going to do today, let's look at what happens if the price of X falls. So if the price of X over here falls, what that means is that we can afford more of the good X. So effectively, our income has risen. And so what that's going to be reflected as is a shift of the budget constraint here. So it allows us to go from utility A, out to utility B because we have this new budget line right here. And so we move out this direction and we have a new tangency point right here. So once the price of X falls, we can consume this level of X and this level, or that level of X and this level of Y. And so if we then want to look at, so this is how we, a very simple way of sort of deriving demand graphically, is that then once you have this change in income and it shifts the budget curve, you're out on a new budget line. What that allows you to do, if we keep good X on the horizontal axis and we put the price of X on the vertical axis, we then can look at the demand function. And so this allows us to go from something unmeasurable, utility, down to something that we can measure, demand. So in this case, demand is what we're looking at is how much of good X we would wish to consume for any given price P of X. And so that's what the linear demand curve is. So we can look at any point along this curve, so this point right here, and we can see that at this price, Px1, that will consume this much of good X. Okay? And for any point along this curve, it tells us how much X we're going to consume for any given price P. That is reflected in this linear form of demand where we put basically we have two goods X and Y, or actually I'm sorry, that should be P of X. P of X is our vertical variable Y. I kind of slipped back into this Y is equal to mx plus B. So we have the price of X is equal to the, here we have our slope again, which is going to be the change in Px over the change in X, because the slope of this line here, so this is going to be delta Px, and this is delta X. And so what is the change in the consumption of good X relative to a change in prices? And so if we look at two prices here, we want to see what is the change in the price versus the change in the quantity, and that's the slope of the line. This is our vertical intercept here, and that tells us the choke price basically. So at what price does demand fall to zero, or do we not consume anything at all? And you can see that as we trace out changes in the budget line in the utility world, in the utility sphere, we get a derivation of demand. And so for the most part, there's a lot of complicated ways we can look at that, but just remember that the utility curve and all of the things that are in consumer theory, from Homo economicus and the other things that we talked about in terms of rational economic man, diminishing marginal returns, perfect information, and all those types of things, all come into play to build these utility curves. So these basically describe the tastes and the preferences and how much we want for any given set of prices. And so that's what we have up here, and we can use that information once we change income and change prices to look at for one of the goods at a time, in this case X. We can look at X and the price of X to see how, as price changes, that's going to impact how much we want to consume, and behind all of that is our utility theory. So we can do a related analysis with production theory. Now production theory is a little bit different. Now it's really very, very similar, but typically we don't use the isoquants to derive a supply curve because the production technology and the production function is not the easiest thing to track, but cost functions are pretty easy to construct. And so we tend to go at it from what's called the dual side of the problem instead of the primary side of the problem. And so from a more simple analytical way, it's much easier to kind of look at deriving a supply function from a cost function, knowing that it's embedded in the profit function and that's related to the production function. And so a complicated way of looking at it, but it's still a simple concept, is we use the symbol pi for profit in economics. And we can say that basically profit is equal to your total revenue minus your total cost. So your total revenue function is really the price that you're selling your good for, P, and how much you produce. And how much you produce is a function of the production function, so it appears in the profit function. And then you subtract off your costs. And costs are a function of how much labor and how much capital you use, and what the price of capital are and the price of wages are. So wages is a W, and that's the price of labor. So if you think about your cost function is basically how much labor you use times how much it costs, and then how much, that should be a plus sign, I'm sorry, how much the price of capital times how much capital that you use, and that's a plus sign right there. So you have your total revenue minus your total cost, and so you have here's total revenue minus total cost, and that's going to give you whatever's left over as your profit. And so the simplest way to think about how to derive a supply function or a marginal cost function is to take the cost function and then take the derivative of it to get the marginal cost function. And one of the things that for most markets, and at least for some portion of the curve, we know that the marginal cost function is the supply function. It tells us how much it's going to cost us to produce the next unit, and we'll sell it at that, anything above that price. And so in this case, on the vertical, on the upright panel here, we have our total cost. And so this curve right here is our total cost function. And just to kind of go back, if we want to think about what the isoquants looked like, they looked like something like this. And then you had a budget line. And so that isoquant is really related to that production function, function of capital and labor. And that appears right here in the profit function. So it's part of how we get to the dual problem. But in this case, the more simple and tractable problem is to look at a total cost function, because we know how much capital, we know how much labor, we know how much they cost. So we can take the derivative of the total cost function, which you can see varies and is not a linear. So cost is not linear, and this is because we have diminishing marginal returns. So over some portion of the curve, as we increase our output, our costs are rising, but then we get to a certain point where the costs begin to fall as we continue to produce. But if we go beyond that point, costs begin to rise again. So if we take the derivative of the total cost function, so we take the partial of the total cost function with respect to how much output we're producing, that's what's going to be our marginal cost function. If we're looking in a discrete world, which for most of the stuff will linearize things, make it a little simpler, you're looking at the change in total cost divided by the change in Q, and that's going to be your marginal cost. And if we look at it this way, we can then put, just like we did in the demand side of the market, we put the price on the vertical, and we put the quantity consumed or the quantity demanded on this horizontal axis right here. And so if we look at the slope of the total cost function at different points, we can derive a marginal cost function. And so this is what the marginal cost function, which is simply plotting out all of the marginal plotting out the marginal costs. And so we can go down to this point right here, and we know at that cost we're going to have this price right here and this quantity right here. And if we're up here, we have px1 and q1. Actually, this would be not and not. And so what that just shows us is we can trace out this, and we see that we have increasing marginal costs, which is to say as we use more and more of an item, we get less and less benefit from doing it. And so that's kind of what's related here. And if we look at this portion of the curve right in here, we can see that that's the supply function. So the willingness to pay is just kind of continuing on with what we were doing. We've got demand, and we have so demand is downward sloping, and marginal willingness to pay is the demand curve, and it's also known as the marginal benefit curve. Some of the things that underlie demand relate to the utility function, and these are the determinants of demand: income, taste, preferences, prices of substitutes, and prices of complements. This then gives us basically our demand curve right here, and our demand curve can be rewritten to look like this, where we have the price of X on the left-hand side, and that corresponds to our vertical axis up here. We have the quantity of X over here, and we have some choke price or intercept, and so we can do this. Now, one other thing to keep in mind, all of the things that are on this side are what we call the dependent variables. These are the determinants of demand. So if any of these things changes, then we get a shift of the entire curve. If we're just looking at a different price, we move along the curve. Same thing for supply. So one other not common way to look at it is to say the willingness to accept curve is the supply curve. Now the supply curve comes from the marginal cost curve and the other things that we've talked about. And that's what we have here. And the marginal willingness to pay is the supply curve. It's also known as the marginal cost curve. So marginal cost and supply are the same thing. Now it's upward sloping, and it's how much a supplier is willing to provide in a given price, and that's a function of the costs. The determinants of supply are right here: inputs, technology, price of substitutes. And that's where we're going to have to end this one. We'll continue it in the next series.